In the previous episode, we embarked on a journey to solve the age-old problem of dealing with curve-based sections in Revit. Please check the link in the description if you missed it, as we will continue working with the same old script. So what we did, we selected a model line, divided it, created a coordinate system and a section box. We jumped into some theory and finally automated the section creation. So as a result, we have a row of sections following each other on the whole length of the curve. And although it's already cool, we will make something bigger. We will place our sections on a sheet. As you see, by the end of the lesson, we will get a few sections standing side by side on a sheet and creating a whole view of the desired element. I opened the script from the previous lesson. More likely you will see that there is no sections created. You know why? Well, first we need to select the model line you like the most in your project and run the script. Oh, now it looks so usual we created sections again. But how can we place these sections on a sheet? I want to start from the end. That's why I will look for node that will place viewports on a sheet. For this, I search for viewport dot by sheet view location. Click. I look at the inputs and I see that we already can connect our section views with the view input. The next challenge is to find the sheet. A node that will help us, called Sheets. Let's click on it. It will provide us with the full list of all sheets in the project. You can select any list of the project that you already have, or you can open the project, create a new list, and then select it in this node. When selection is done, let's connect the nodes. I will run the script because I can't stop myself from experimenting. Sadly, no. My hope that there will be some default point is absolutely dead. That's alright, we will create our own point with the help of point.byCoordinate and run the script again. Give it some time. I will open the selected sheet. And what we can see is that all of the 10 section views that we just created are placed on the same point, in the same place. Well, no wonder, because as you remember, we provided them all with only one point. And what we actually need is a list of points. And each point should stand from the previous one on a distance equal to the width of a viewport. You might remember that for a view, this distance would be equal to x. But the viewport is different. For the viewport, our x is scaled. Of course, it's scaled by the value of a view scale. So to take the right distance between the points, we have to take the x as the width of every section view and divide it by a scale. So we have to change the x coordinate. As the length, we can take the length of the vector that was like the core of our script. For this, I search for the node called vector.length. With two simple clicks, I have the length of a section. And as you remember, this length should be divided by the scale. Here, for example, it will be 100. There is a few ways to do that, but in my case, I believe it will be more efficient to set the scale for the view and then use the same scale to find the length of a viewport. For this, I search for the node view.setScale. In case if you, for example, set a view template on your view, or if for some any other reason you don't want to change the scale of a view, you can search for a node view.scale The logic will be the same, the script will be slightly different. For now, let's connect our node with the views. We need to set the scale. For this, let's search for integer.slider. I customize the node just a little bit. I rename the node as scale12 space. And this space will represent the number that we will select in the integer slider. 1 to 100, 1 to 200, 1 to 50, and so on. And as before, I style it as input. Of course, don't forget to check the input checkbox. I also renamed the group, just like before. So once again, the number that we will set in the integer slider equals to the number that stands after 1 colon in the scale view. For example, here it is 100. And connect it with the view.setScale. Let's set the scale that you like the most. I will set 200 and run the script. Let's check how it works. So as you see, now we have the scale of 1 colon 200. But remember, instead of these two nodes, you can simply use view.scale. And now we need to create some space to make magic with x coordinate. As you see, we already have a list of x lengths. But can we just simply provide these values with the x coordinate values? Well, sadly, the answer is no. Because if we do this, we will receive the list of points that are standing on the same location with the same coordinates. What we need is to add the previous x value to the next one, so the points will have the perfect distance between them. And it might be quite a nervous moment for some of you, but now we need to use Python script node. I connect it to the list of lengths and open it. To open it, you just simply need to click twice on the empty space of a node. All you need is just to follow the link in the description and copy all the lines in the file. And you just have to paste it there inside of the Python script node. After you do this, save it. Let's run the script now. So what we see as the result is that now each of the x coordinate will stand from the previous one on the direct length of the view. And what about now? Can we connect these values with the x coordinate? Also, we have values that are standing one from another. To put it on a sheet, we still need to scale them exactly. Let's click twice on a blank workspace and we will see the code block. I will type there length divided by scale. Be careful with the naming and don't use capital letters. Python script node will be connected to length and the integer slider node will be connected to scale. Let's run the script again. And this perfect list we can finally connect to the x coordinate. Let's run the script and see the outcome. What we see is that all of the views standing perfectly attached to each other, except to one that has a section on it. And it's time for us to create a place to modify our views before placing them on a sheet. Basically, the core of our script is done. What we will do now is just smooth its work. And first, let's connect view set scale node to the node that places the view on a sheet. And here is the best place to change the view parameter. You can set the name, the view template, or change any other parameter that you feel like you want to change. Keep it in mind if you have any future plans on the script, and we will continue working. But my plan now is to hide the elements that might ruin the perfect placement of our views on the sheet. For this, I search for the node called view.set category overrides. As we see, we have to provide the node with the view. So we take the view and also we will reconnect the final view that we will place on a sheet with the view that we will have after we run the script with this node. Now we need to provide categories that we want to hide. I search for the node called categories and pick sections category. I connect this node to the category input and I search for a Boolean node. That will represent that we want to hide the category that we just selected. So I will set the Boolean value to true and connect it to the hide input. The only remaining input is overrides. For this, I search for override graphic settings and I choose the node by properties. It's already full of default values, so we don't have to put anything for this node. We just simply connect it to our node. Once it's done, let's try the magic and run the script. Perfect! Now every view sits the way it should, and it's in the perfect order, aligned to each other in the best way possible. But what if we still need sections? What if the categories, and there might be some other categories in your particular situation that ruin the game, you actually need them on the sheet? Can we first hide them, place views on the sheet, and then make them visible again? Well, let's try to do that. So the idea is we hide it here, place on the sheet, and then unhide it. The output in the last nodes are viewports, so we have to take views from the viewports. For this, I search for the node called viewport.view. I connect them. And what I need to do now is copy the node called view set category overrides. I move it to the end of the script and connect it to the new view. And of course, we have to unhide our elements. So for this, we search for Boolean node, and the value should be false. We connect this node to the hide input. Let's run our script and check how it works. Great, the views placed the way they should be placed, and the capricious category is also visible. And if you now don't have the perfect order with your capricious category even after hiding and unhiding it, don't worry. We will make additional steps to make our script work more stable. I select the nodes that changes the view and create a group, perfect place to change view parameters. As I said, this is the perfect place to change the view according to your taste and requirements of your project. Now, if we look on our sheet, we will see that there is a few things that still stops our views from looking like one solid view. For example, crop boxes. To get rid of them, I search for the node called view.setCropBoxVisible. And I insert this node in our chain of changed view. This node also needs a boolean as an input, so I search for boolean. I leave the false value as I don't want the crop boxes to be visible and connect it to the node. I will add these nodes to our change parameters group. Let's run our script and check how it works. Perfect, now our crop boxes are no longer visible, but we have a few more disadvantages. For example, the capricious view with a section stands out again. Let's be patient and correct it. In our script, there are two important steps of changing the model. First one is creating the views and place them on the sheet. The second one is changing the views again after placement. In Dynamo, it's best to separate these two logical steps. So we know for sure that the second one will be started when the first one already be totally finished. In this case, we will be sure that our views are placed perfectly in the first step, and in the second step, it's safe to change them however we want, and the changes will not affect their placement. I will create a new group of nodes that make changes in the views after placement. I will call it second step, changes after the placement. So every node that was before is the node of the first step. This is the first step. And this is the second. But how do we separate them? Not just graphically and on the screen. Just like in any program, to be sure that the first step will be finished when the second one will start, we will use transactions. I search for transaction. Let's click on Start. I will drag this node to the very beginning of the script. And let's make it a tie between the first and the second. So the information should go through the transaction start node. So we already know where is the beginning of our transaction, of our first step. Now we have to put the end of it. For this, I use transaction.end. The logic is the same. I have to pass the connection between these two borderline nodes with the help of a new node. Be careful and reconnect them properly. We can leave it as it is, but I want to make sure that Dynamo knows that the second step needs its own transaction. So I click on the transaction start again. You already know what to do. You need to pass the connection between borderline nodes with the help of our new node. And of course, let's add the last transaction end node. So as you see, the border between our transactions are exactly on the border between the first and second step. Let's run our script and check how it works. But I see one big problem here. Seems like although the views are placed in the perfect order, the direction of each view seems to be not co-directed with the solid view direction. In my project, on the solid view, the black line seems to be going up, but in every view separately, it seems to be going down. Let's go and solve this mystery. I hope you remember about the workaround I was telling you in the end of the last video. Let's find the best combination of values for flip section direction and flip x direction. First, I will change flip x direction. I don't know how about you, but for me it's not quite what I wanted. Now I additionally change the flip section direction and run the script. Perfect, now each view has the same direction as the solid view. And of course, if it's needed and you see that you need a smoother lines on the border of each section, you can increase the number of sections. I run the script again, and I would say that I find this result quite satisfying. Now let's test our script on another model line. I select this line in the script. I leave flip section nodes as they are, and run the script. This section looks amazing. I hope so does yours. For sure, you might have your own standards in the company, and I don't want to overcomplicate the script, but I will give you a hint how to turn off the names of the views. Select all the section views on the sheet. Click Edit Type. Click Duplicate and create a new name if it's needed. Uncheck Parameter, Show Extension Line. Pick Null for the Show Title parameter. And simply click OK. That's amazing, isn't it? Now script is totally yours. You're free to adjust it the way you need for your own project or your company. By the way, if you have some impressive results creating curve-based solid view and you would like to share it, feel free to tag me on LinkedIn or share your work in the comments. A friendly reminder to style your beautiful script in the end of your work. And don't forget to make our sheet an input. To celebrate Christmas, we decided to collect your wishes and create a free Revit plugin. Now, when you know the specific of creation of curved sections, you probably have your wishes and your own vision of your dream plugin button that could do the work even better than the script. And as a little beam Santa Claus, we are ready to make your dreams come true. Leave your wishes here or on the LinkedIn post. Thank you for watching and Merry Christmas and Happy New Year!